Welcome again. In this lesson, we are going to talk about the numbers in detail. A number is an arithmetic entity that lets us measure something. Python allows us to store the integer, floating, and complex numbers and also lets us convert between them. Python is dynamically typed and hence there is no need to specify the type of the data for a variable. Let us start with the Python number types. Here I am starting with the integer type. Python can hold signed integers. For example, here a is equal to 5, and if I type or if I print a, then we will get the value of a as 5. Python integer can hold a value of any length, the only limitation being the amount of memory available. For example, here I have entered a long integer value for the variable a. Let us print the type of the variable a. So here you can see it belongs to the class int. Next we have the instance function. The instance method returns true or false based on whether the construct belongs to that class. Suppose if we want to check whether the integer value entered belongs to the class integer or not, we can use isInstance method. For example, here I have entered a. We know that the interpreter or the program flow will look for the recent value available for the particular variable. So here for a we have this long integer. If I use the isInstance method to check whether the number belongs to boolean or whether the number belongs to an integer. This isInstance method takes two arguments, default two arguments. One is the variable and the type of the class which belongs to. So here first I have taken boolean and then I have taken the integer. Let us print this statement first by pressing F9. So result, look at here, the result is false because a is of type integer. It is not of type boolean expression, that is true or false, right? In the second statement I have taken integer instead of boolean. So let us print this. So now we got the output as true because the value of the variable a is of type int. Let us look at how to create the exponential numbers. We can create an exponential number using the letter e between the mantissa and the exponent. For example, here I have created a variable a with the exponential number value, that is 2 into e to the power of 2. So here the exponential e is with respect to the base 10. The default exponential value is 10. So 10 to the power of 2. So e2 is nothing but equal to 10 to the power of 2. So 2 into e to the power of 2. Here I can't use the star symbol, otherwise it results an error. there should not be any special characters between E and the number. And similarly here, if I use star for this exponential number and with the integer number, then this exponential number will not be used as an exponential number, because this will be treated as a normal integer value, and it will look for that normal integer value. If it does not match with the normal integer value, then we will get an error. So avoid using the special characters when you are using the exponential function. Okay, so here I have created an exponential 2 into 10 to the power of 2 with exponential term e, and let us print this value. So here we got 200, and let me check the type of the value. So by default the exponential number will create a floating point number. So this 2 into exponential to the power of 2 is equivalent to 2 into 10 to the power of 2. Again, look at here, but the value obtained in this method, that is 2 into 10 to the power of 2, the normal mathematics, is of type int instead of float. The value remains same, that is 200, but it is of type integer, not float. So if you want the floating point number with respect to the exponential term, use this exponential function, otherwise use the normal method, that is arithmetic method, using an arithmetic operation, that is 2 into 10 to the power of 2. So we will get an integer value. So the important thing here to notice is the exponential term e is used to create powered values with the base 10. To raise a number to another base power, we can use the arithmetic double star operator, that is rising power operator. We all know that Python supports the floating point real values. So here I have entered a floating value for the variable a, an arbitrary floating point value for the variable a. This floating point value is only accurate up to 15 decimal places. After that, it rounds up the number. For example, here I have entered a floating point value with more than 15 digits after the decimal point. Let us print this variable and see what happens. So look at here, after the 15 decimal place, it rounds off the number. So here, look at here, the last two numbers 1 3, here we have 1 2, and then still we have 6 numbers 3 4 7 8 9 8. but it is rounding off these 6 numbers and making this number 2 as nearest upper value, that is 3. So this whole number 6 values have been replaced with the number 3. It is rounding off. Whenever we divide using the two integer values, the result will be in floating point number. For example, here I have taken a is equal to 2 and b is equal to 3. These two are the integer values. But if I use these two integer values to do an division operation, we will get the result in the form of floating point number. So look at here, the result is in floating point value. In Python, the complex number is made up of real and imaginary parts, and this is true in the real mathematics also. The complex numbers are represented as a plus b and then the term j. Here the character j is used to represent the imaginary term. So a is of type real and b, this is the coefficient of the imaginary part. So this is the real part and this is the imaginary part, and imaginary part must and should have the coefficient. For example, here 2 plus 3j, it is nothing but a complex number. If I check with the type method, we will get the type as complex. So here we got the complex. Providing coefficient for j means for the imaginary part is mandatory to create a complex numbers. If you think that if you do not provide any number for j, in mathematics by default it will consider as 1 and it will create 3 plus 1j. But in Python programming language, it will not create complex numbers unless until we provide the coefficient for the imaginary term j. So if I try to create an complex number without providing an imaginary coefficient, means the coefficient for the imaginary part, then it will result an error. Let us try to look at here. The interpreter is not showing an error, but after evaluating this program, we will get an error. Name j is not defined. Okay, so it will treat this j as an just as variable, and it will give an error as j is not defined, so name error. So let us replace this j with 1j. Okay, so let us create an imaginary part by using 1 with the imaginary term, that is j. So now we got the imaginary number 1j in the complex number 3 plus 1j. We cannot use I term here to create an imaginary or the complex number, otherwise it results in error. So we normally use I term in mathematics. Some authors use it to represent the complex numbers imaginary term with the I term or with the I letter, but it is not going to happen in Python. In Python we have to use J. It is mandatory, okay? And also the coefficient for J is mandatory to create an zero imaginary part or the real valued imaginary part, okay? Means the integer value imaginary part or zero imaginary part. We can perform arithmetic operations on complex numbers. For example, here I have taken A as 2 plus 2j and B as 1 plus 1j. These two are the complex numbers. Let us perform some arithmetic operations on these two complex numbers. And remember that in mathematics we know that j square is nothing but minus 1. When we square the imaginary term j, we will get the value as minus 1. The same thing will be applied here also. So let us do an addition first. A plus b. The real parts will be added separately and the imaginary parts will be added separately while we adding the two complex numbers. Okay. So look at here the result 3 plus 3j. 2 plus 1 is 3 and 2 plus 1 is 3. 3 plus 3j. Similarly the subtraction a minus b. The real parts will be subtracted separately and the imaginary parts will be subtracted separately. But the thing is this subtraction is going to take place like this. In mathematics also it is like a is nothing but 2 plus 2j minus of 1 plus 1j. Look at here, this real part and this real part. If you have negative sign in this real part in the second complex number, then negative of negative becomes positive. So instead of subtraction the addition will take place. Similarly for the imaginary number 2j, this is plus 2j and here we have plus 1j, but we are using subtraction. So plus 2j minus of plus 1j, plus into minus becomes minus, then plus 2j minus 1j becomes 1j. If you have negative number here, then minus into minus becomes positive. Then instead of subtraction addition will be taken place. Okay, so please remember the complex numbers subtraction will happen like this. Okay, addition will also takes place in this manner only. Let us see what is the result. Yes, 2 minus 1 is 1 and 2j minus 1j is nothing but 1j. Let us do the multiplication. Multiplication takes place like this. 2 plus 2j star 1 plus 1j, and we know that j square is nothing but minus 1. So first the real number will be multiplied with these two, with this complex number, and the imaginary term 1j is multiplied with the first complex number. 1 into 2 plus 2j is nothing but 2 plus 2j only, plus 1j multiplied with the 2 is nothing but 2j, and 1j multiplied with the 2j is nothing but 2j square. So j square becomes minus 1. So 2j square means minus 2. We have 2 plus 2j plus 1j minus 2j. So let us see the result. So we have 4j, because 2j minus of 2j becomes minus of minus 2j becomes 4j. 2 plus 2j, when we multiply 1 with these complex numbers, the second complex number, if we take 1 and multiply with this number, we will get 2 plus 2j, and when we multiply with the second term, that is 1j, with the first complex number, 1j into 2 is nothing but 2j, plus 1j into 2j is nothing but 2j square, right? 2 to the power of 2, sorry, j to the power of 2. So then j square is nothing but what? Minus 1. So this term becomes minus 1. Minus 1 into 2 is nothing but what? Minus 2. So this term becomes minus 2. So 2 minus 2 becomes 0. We left with 2j plus 2j, that is nothing but 4j. Similarly, the division, when we divide one complex number with the another complex number, then complex conjugate of the denominator will be multiplied with both the numerator and denominator, and then the multiplication will take place and the result will be displayed. Okay, so we know how to do the division operation for the complex numbers. Let us display the result. So we got 2 plus 0j. Suppose if you would like to know whether j square becomes minus 1 or not, take out the imaginary term 1j, then square it using the power term, that is power operator, 1j to the power of 2. Let us see the result. Yeah, look at here, it becomes minus 1. We can also use the in-place assignment operator on complex number. That is, for example, if you have a real number, in order to add, subtract, multiply or divide with another number, we use the in-place assignment operator, like a is equal to, a plus is equal to a for addition, and for subtraction minus, multiplication star, and for division the division operator. Similarly, we can use this in-place assignment operator to do arithmetic operations on complex number. For example, here 2 plus 2j is the complex number assigned for the variable a. So a plus is equal to 2 plus 4j becomes a plus is equal to another number, that is another complex number, for example here b. So this will be equal to a is equal to a plus b. So a here is 2 plus 2j and b here is 2 plus 4j. Directly we can assign the value. Okay, so directly we are using one more complex number, that is 2 plus 4j. 2 plus 2j plus 2 plus 4j becomes 4 plus 6j. Let us print the result. So we got the result as 4 plus 6j. Let us see how to write the numbers in binary, octal and hexadecimal in Python. In order to write a binary number, we need to use the prefix either 0 small b or 0 capital B. So 0 small b or 0 capital B in front of the binary digits, that is 0 and 1. We know the binary number consists of only two digits, either 0 and 1. For example here, if we want to express or write the binary number 1011, we need to use the prefix 0b. Then only these numbers 1011 or these digits will be considered as binary number, otherwise it will be treated as a normal integer value. If we do not use 0b, it will be treated as an integer value. Suppose if I type the type of the value assigned without the prefix 0b, then it will result integer value. So let us see. Look at here, it is of type int. If we use 0 and then small b, and then if we type of the number, again we are getting in the form of int, because this will convert the binary value or the binary number into an integer value, and then the value will be assigned to this variable bn1. That's why it is printing the type as int, but actually it is a binary number. This number will be converted to an int before it will be assigned to the variable bn1. So don't get confused with the operation, how it happens. Okay, so similarly, as I told you earlier, we can use capital B to create an binary number. So 0 capital B 1011. So 1011, if we convert this binary number to an integer value, we will get 11. We can convert the binary numbers into an integer using the int function. This is nothing but typecasting. So here we are directly assigning the converted value to the variable, but here we are using the typecasting method directly to print the value of the binary number in the form of an integer value. So here we got 11 once again. To create an octal numbers in Python, we can use the prefix 0 and then small o, or 0 and then the capital O. We know that the octal numbers varies from 0 to 7. So let us create one simple octal number with the prefix 0O, small o. Here I am using 1234 as the simple octal number, 4-digit octal number, and I am creating with the capital O for the same digits 1, 2, 3, 4. So the octal number of 1, 2, 3, 4, the integer value after converting this octal number is nothing but 668. And as I said earlier, the octal number has the numbers from 0 to 7. If we try to use the number 8 which is greater than 7, then we cannot able to create the octal number, because the octal number varies from 0 to 7. Okay, the numbers varies from 0 to 7. That's why we can't use 8 to create an octal number. Similarly, how we cannot create an binary number with the digits greater than 1. You cannot use 2, 3 or 4 to create an binary number, right? Similarly, we cannot create an octal number by using the digit which is greater than 7. So here already the spider editor is showing the invalid digit. It is showing an error. The code analysis is showing an error, invalid digit 8 in octal literal. If at all if we try to create, we will get an error, the same error, syntax error. Let us replace this with 7 and see what happens. This is the integer conversion of the octal number 1, 2, 3, 4, 7. Next we have an hexadecimal numbers. We know that the hexadecimal numbers has the numbers from 0 to 9 and then A to F. The hexadecimal number system has numbers from 0 to 9 and then A to F. A is nothing but 10, B is nothing but 11, and so on. So here I am creating an hexadecimal number. In order to create an hexadecimal number, we need to use the prefix x, 0x, 0 and then small x or capital X. So before the leading digits, okay, so 0x and then 1 2 3 4, we can use up to 9, 1 2 3 4 5 6 7 8 9. Here I am creating 4 digit hexadecimal number 1 2 3 4 by using the prefix 0x, and also I am using a instead of using 10. So look at here, a only 2 digits 1 2, and then I am using a. Let us see how it will create. Here the hexadecimal 1 to a is nothing but 1 2 and then 10. The hexadecimal value of 1 2 and then 1 0, that is 10, is nothing but 298. Let's see, 1 2 and then a is nothing but 1 0, is equivalent to 0 into 16 to the power of 0 plus 1 into 16 to the power of 1, 2 into 16 to the power of 2, 1 into 16 to the power of 3.
ಏನು ಕೆಲಸ ಅಂತ
ನಾನೀಗ ಮಾಡೋಣ ಕಾಫಿ ಕೊಡ್ದವ್ರಿ. Let us see how we can able to see whether a is 10 and b is 11 in hexadecimal number system. Here I am printing hexadecimal number a with the prefix 0x and b with the prefix 0x, and similarly I can print the value of c and the value of d and the value of e, and finally the value of f. So 10 11 12 13 14 15. Next we have Python conversion functions. Most of the times Python does the conversion as needed, but we can do it explicitly if we want. So these functions means Python conversion functions allow us to convert one numeric type into another Python numeric data types. For example, here I am using the int function to convert the floating point number into an integer value. So here it is floating point number, and I am passing this floating point number inside the int function to convert it to an integer value. So here we got an integer value after the conversion. Look at here. The converted integer value has rounded off to an lowest integer value, that is 2.745678 has been converted to 2 only. The remaining decimal numbers have been ignored. We cannot convert the complex number to an integer value. If we try to convert the complex number to an integer value, we will get an error. For example, here a is equal to 2 plus 2j. If we try to convert this complex number to an integer value, we will get an error. So it will not convert the complex number to an absolute value or to the magnitude and then result. So it will give an error. So look at here, it is type error. Cannot convert complex to an integer value. Remember the error type error. Okay. But we can convert the floating point values, binary values, octal and hexadecimal number values to an integer value. For example, here I have taken an binary value to convert it into an integer value, and then the octal number, and then the hexadecimal number. We know already how to convert the floating point number into an integer value. Let us run this cell. So we got the binary, octal and hexadecimal numbers in the form of integer. We can use the float function to convert the integer, binary, octal and hexadecimal numbers into an floating point number. So here I am converting 12 to the floating point value, and then this binary number 1011 to an floating point value, octal number, and then the hexadecimal number. But we cannot convert, or we cannot typecast the complex number into an floating point value, otherwise it results an error. Let me first convert these binary, integer, octal and hexadecimal numbers into an floating point numbers, and then try to convert the complex number and see what happens. So look at the error, type error, cannot convert complex to float. We can use complex function to create a complex number. So this complex number takes two arguments, one the real number and another number for the imaginary part. One argument for the real number, integer argument, and another for the real part. Here I have taken the complex function. Inside the parenthesis I am using the two arguments, for example here 2 and 3. Let us see what happens. So it has created the complex number 2 plus 3j. If we use only the single value, that is 2, inside the complex function, then it will create complex number with 0 imaginary part. Suppose if we use only the imaginary part inside the complex number, then it will create the complex number with the only imaginary part. It means 0 plus 8j. What happens if we use the complex type directly or the complex number directly inside the complex function? Let us see what happens. It will just create the complex number as it is. Okay. We can also use the variables instead of the direct default values for the arguments. So here I am using a as an one argument for the real number and b as the another argument for the imaginary number. For real number I am using 4 and for the imaginary coefficient I am using 3. So let us create a complex number with these two values. So we got 4 plus 3j. Let us take small break with t. Okay. It's coffee, not tea. It's okay. Hi, let us continue. We can create the binary numbers using the binary function, that is bin. Here I am creating the binary number for the integer value 10 and for the integer value 200, 255 and 256. Let us see what happens. So 10 can be expressed in the binary form as 1010 and 200 as 1100100, and we know that the highest value in 8-bit binary number is nothing but 11111111. All the 8 digits have 1. And 256, look at here, for 256 we have 9-digit binary number instead of 8-digit, because 255 will end for the 8-digit binary number. So in order to get number which is greater than 255, the binary number will create 9-digit binary number, means the binary function. We cannot convert float and complex numbers to binary form. If we try to create a binary number with the floating point and the complex numbers, we will get an error. Float object cannot be interpreted as an integer, and similarly complex number cannot be interpreted as an integer. Similar to binary function, we can use the octal function to create an octal number for the integer values. For example, here 9, and for 255 I am creating an octal number. So the octal number of 9 is nothing but 1111, and the octal number of 255 is nothing but 377. Because in octal the numbers the system as numbers from 0 to 7. So 9, if you look at here, 1 1 1 into 8 to the power of 0 plus 1 into 8 to the power of 1. 8 plus 1 is nothing but 9. If we try to convert the floating point value into an octal number, the interpreter will throw an error. So we got type error. Float object cannot be interpreted as an integer. Similarly, we can use the hexadecimal function to convert the integer value to an hexadecimal value. Let us see first for the integer value. We got the hexadecimal value as FF. Let us see whether we can create the hexadecimal number for the floating point or not. Here we have floating point value or floating point number. We cannot create an hexadecimal number with the float object, but we can create for integers, and also we cannot create the hexadecimal number for the complex number. Let us see for the complex number 10 plus 2j. So we got an error, type error, but for the integers we can create the complex number, the hexadecimal number. Next we are going to talk about the number type conversion. Python allows the conversion of data from one type to another type. We have already seen, but how it happens? It happens in two types. One is implicit type conversion and another one is explicit type conversion. Let us talk about the implicit type conversion. In case of two compatible data types, Python performs the type conversion implicitly. Compatible data types are in general two numeric data types like int and float. It will convert the smaller data type to larger one to prevent any data loss. Here, the smaller data type is nothing but int and the larger data type is nothing but float. Hence, int will be converted into an float implicitly during the operation. For example, here I have x is equal to 99 and y is equal to 1.11. Suppose if I try to add these two numbers, x plus y, then look at here, this 99 will be converted into an floating point value. That is the definition of implicit type conversion. It will convert the smaller data type to an larger one to prevent any data loss. Here, larger means not in the form of magnitude. In the float, always takes higher priority than the integer. Okay, so this addition will convert x to an floating point value first, and then it will add 1.11 to an floating point value. Let us print the result g. Here we got 100.11. So obviously this floating point number, if we try to check it with the type method, we will get an floating point value. Yes, it is of type float. Let us look at the explicit type conversion. We can convert data type in one type to another explicitly using the int, float, and complex functions. So this is called as an typecasting. For example, here I have a is equal to, say for example 30 integer value, and b is equal to some string value, say for example Prithvi. Suppose if I want to add these two variables, then I need to use the typecasting using the string function. Directly I cannot use the string to add with the integer value 30. I need to convert it to an integer value. Let us convert either I can convert this Prithvi to an integer value, or this integer value to an string, that is 30 to an string value. Let us check whether we can able to convert the string value to an integer value. So we got an error, value error, invalid literal for int with base 10. So we cannot convert string value into an integer value. So let us use string function to convert the integer value to an string value. Here the integer value is 30. Yes, 30 has been converted to an string value. Let us see the type of the converted value. Yes, it is of type string. Now we can add like a plus b, but we need to convert a to an string value, right? It is because a is of type integer. So use this typecasting method to convert the integer value to an string value, and then add it to the string value. So we got 30 Prithvi. Two strings have been concatenated. If we want space in between 30 and Prithvi, we need to use single space between two strings. So we got 30 space and then Prithvi. So this is how the implicit type conversion and the explicit type conversion happens in Python. Let us move on to the math module methods to work with the numerical data. Python has built-in methods to perform complex mathematical operations. So in order to use them, we need to import the math module first using the import statement. Import and then math. Let's see what is the error. Math imported but unused. Okay, we can import this module as alias name. For example, here I am using m. Import math as m. So we talk about the modules later in this course. For now, you just concentrate on how to work with the math module to do certain mathematical operations. Here we are going to see the most widely used math methods with example. Let us start with the ceil function. Ceil and the one more method, that is floor. These two methods are used to round a float number to the nearest integer. As the name suggests, ceil method is used to round up the number up to the nearest integer value, while the floor is used to round up a number down to the nearest integer value. So ceil is used to round up to the nearest integer value, whereas floor is down to the nearest integer value. Okay, let us see, for example, a is equal to 1.7. I can use m dot ceil. M dot ceil, m means math dot ceil. It is like math, okay, but we are calling math as m using the alias name m. M dot ceil, inside the parenthesis it takes the argument x, and look at here, it supports float, okay, and then it will convert to an integer value up to the nearest integer value, okay, up to the nearest integer value. Let us see how it creates. So look at here, the nearest value for 1.7 is 2, not 1, right? Yes, this is up to the nearest integer value. The floor value m dot floor, okay, it will convert the floating point value down to the nearest integer value. So let us convert, yeah, sorry, yes, we got 1 down to the nearest integer value, 1.1, sorry, 1.7 the nearest down value is 1. Let us see how to work with the degrees and radians. In trigonometric calculations, we represent angles in both degrees and also in radians. So here we use the degrees method of math to convert the angle in radians to degrees, and the radians method to convert the angle in degrees to radians. Math module also provides some frequently used constants like pi. Okay, this is nothing but a constant. For example, let us print m dot pi. So here I would like to print the pi value. So here is the pi value 3.141592653589793. Let us convert this pi value, which is in radians. We can convert this radian into a degree using the degrees function. M dot degrees, and then inside the constant, that is m dot pi. So m dot degrees, this degrees function will convert the angles in radians into an degrees. So m dot pi, this pi is in radians, so we are converting it into an degrees. Let us see what happens. So we got 180. Yes, obviously pi is nothing but 180 in mathematics. Let us convert the degree in means the angle in degrees to an radians. For example, 90, it is in degrees, 90 degree. Okay, so I would like to convert it to an radians. Let us convert this into an radian. So we got 1.57. We can use the sine and cos functions to find the trigonometric sine and cos values using the built-in methods which are available in math module. So we can find the sine value of an angle in radians using the sine method. And similarly, we can find the cos value of the angles in radians using the cos method. We can also use tan and other hyperbolic functions, okay, like sin h, cos h, and tan h. Let us convert or find the sine value of the radians 90 degree. Okay, first we need to find the radians of 90 degree. Okay, use r underscore 90 degree, means radians in 90 degree is nothing but math dot m dot radians, then 90 degree. So we have created the 90 degree in radians, okay, using the radians function m dot radians. That is 1.570 and something, that is floating point value. This is radians. Let us create the sine value of this one, sine, and then the radians. So this sine function will create the sine value of an angle in radians. R underscore 90, it is in radian. Okay, let us create the sine value. Yes, we know that sine 90 degree is nothing but 1. Similarly, we can create the cos value for example here, cos 90. Okay, let us see what happens. Cos 90 is nothing but 0. Look at here, 6.123 and e to the power of minus 17, very less value, that is 0. Similarly, we can create the tan value using m dot tan. Okay, so look at here, we are having tan and tan h, hyperbolic tan and tan and then r underscore 90 degree. So the radians of 90 degree is nothing but 1.57. Let us create the tan value of this 90 degree in radians. It is 1.633 into e to the power of plus 16. We can use the factorial function to create the factorial of any positive integer which is available in the math module. So this method will return the factorial value means the multiplication of all the numbers from the specified number until 1. For example, here the factorial of example, 4 is nothing but 4 multiplied by 3, 4 minus 1, and then 3, 3 minus 1 is 2, and then 1. Let us see this with the math module. M dot factorial. So we got here the factorial method or function. It finds the factorial. Okay, it will raise an value error if we provide negative or non-integer value. Let us create the factorial number for 4, positive 4. So we know that the factorial of 4 is nothing but 24. If we provide negative value, it will give an error, value error. Factorial not defined for negative values. For string also we cannot create the factorial. String object cannot be interpreted as an integer. So string will be treated as a type error, whereas negative value is treated as an value error. Because string is of type string, so it will treat it as a type error instead of value error. Next we have absolute value function and then truncation function. We can use the f absolute method in the math module to find a number's absolute value as a floating point value, and then the truncation method to truncate a number to its nearest integer value. This truncation method will not return the number as it is, it will truncate the number to its nearest integer value. Okay, whereas this absolute f absolute method will results the value as an absolute value in the form of a floating point number. Okay, and this absolute function will remove the negative sign if any and return only the absolute float value. So obviously absolute means return only the positive value by removing the negative numbers, the negative sign if any in the number. Let us see how to work with this. M dot f absolute. So we have f absolute. Let us pass the negative number, for example minus 100. Let us see what happens. We got plus 100 in the form of floating point value. Let us use the truncation method, m dot truncation method. It will truncate the real x to the nearest integer value toward 0. So let us use 12 point, for example 56. what happens. So we got 12, the nearest integer value. If you use negative sign in the truncation method, you will get the negative nearest integer value. The sign will be kept as it is. So the f absolute method will return the floating point value by removing the negative sign, whereas the truncation method results the nearest integer value keeping the negative sign as it is. Next we have power and log methods. We can use power method to create the value of x raised to the power of some other value. Means x value raised to power with some other value, for example y. So it accepts two arguments, means two values. And the log method will find the natural log value of the number using the natural method. Okay, let us create an 2 to the power of 3, for example here. So x is nothing but 2 and y is nothing but 3. So it is nothing but 2 to the power of 3. So we know that 2 to the power of 3 is nothing but 8. Yes, it results in floating point value. Let us use the log function. It returns the logarithm of x to the given base. If the base value is not specified, then it returns the natural logarithm of x with the base e. So e is nothing but what? The natural logarithmic value, that is e. Let us see what is e here. Suppose I would like to create the natural log value of, say for example 0. Math domain error. Let us use 1 instead of 0 and see what happens. So the natural log value of 1 is 0. For 100, the natural log value of 100 is nothing but 4.6051. Now in math module we have some other functions, specific functions. to check whether the number is finite or infinite. So these are called as checking functions. We can also check whether an argument is number or not using isNan method. So here is infinite method is used to check whether the number is infinite or not. Then is finite method is used to check whether the number is finite or not. And then is nan method is used to check whether the argument is number or not. Let us use one by one. For example, here I would like to check is finite method. It returns true if x is neither an infinitely nor nan, and false otherwise. So x should not be an infinite value, or it should not be an nan. Okay. For example, here if I would like to use the nan value, for example, non, not a number, then it results type error, must be real number, not non-type. Okay. Let us use for example 4. What it results? True, because it is an finite number. If you use negative sign, then also it results it is an finite number. True. Let us check whether m dot infinite math dot infinite value is finite or not. We can create infinite number using math dot infinite, m dot infinite. Okay. It results false because infinite number is not an finite number, so it results false. If we use this m dot infinite inside the math dot finite is finite, okay, sorry, is infinite instead of finite, is infinite, then we will get true. Yes, we got true. Infinite is infinite. Using, we are checking infinite value using is infinite. If we use other than infinite value, for example 4, then we will get an error. So we got false because 4 is not an infinite number. If we use m dot nan method, that is m dot nan is nothing but not a number, okay, inside this is infinite or is finite method, then we will get false. So not a number is neither an finite number nor an infinite number, because it is not a number, okay, not at all a number, so we got false. We can use this m.nan to check whether the number entered is not a number or not. M dot is nan. Inside that, let us use nan, not a number, first, and then check what it results. It results true because not a number is checked with is not a number. Yes, it is not a number, so it results true. Let us use 4 instead of not a number. 4 is not a number, it is number. 4 is an integer value, it is not a number. Okay, it is not of type nan. So while pronouncing it, looks like not a number. Okay, so don't get confused, it is not of type nan. 4 is an integer value. In simple, we can say 4 is not a nan. Okay, so it results false because 4 is an integer value. We are checking with is nan. So we can do many other things with the math module.